Okay, so we'll now look at table creation. Okay, so I download my SQL from this link posted here and go through the installation process. And we should be able to eventually get this command line window. So all our queries will be placed through this window and will be processing. We'll not use any GUI for any of these things in this chapter. Okay, so assuming that you've gone through the installation and have this command line window appearing, we'll now get started. So the attributes or the columns, that's what they are called in the table, could be of different data types. The first thing is it could be an int or a float, as well as date. Date is entered as a string in this format. The 4-digit year, hyphen a 2-digit month, and the hyphen and 2-digit day. And string can be entered either using a single quote or double quote, does not really matter. And in addition to int and float, you can also have numeric data type. So it could be like numeric of say 8,2. So what it means is you could have 6 digits for the before the decimal and 2 digits after the decimal. That's what it means. So totally they add up to 8 digits. And then so 6 digits before the decimal and 2 digits after the decimal. Now you also have two types for character. When you say character or char of 4, it means that attribute can have 4 characters as part of its value. Now, you don't need to have exactly 4 characters, but preferably use char of 4 mostly when you need exactly 4 characters. I'll tell you the reason. If in case you enter less than 4 characters, let's say you enter something like this, 301. So it could be a mix of numeric and characters, and you could call still as char of 4. The missing 1 character will be filled by as a blank space. Okay, so still definitely 4 characters will be used for each row in that attribute. So attributes are the rows. So attributes are the columns. Attribute means column, and row is also called tuple. Okay, so each row will have some value for each attribute. And if you don't enter exactly 4 characters, if you define that attribute to be char of 4 at a time, then the missing characters toward the right would be filled with blank space. So if you're not sure how many characters your attribute will take, then the preferred data type in MySQL is varchar. So let's say you know that at most the attribute could take 20 characters. Say, for example, the name of some um, uh, customer or a student. You could specify varchar of say 20 or 30, and you don't need to have 30 characters all the time. You could enter even 10 characters, and space will be allocated only for 10 characters, unlike char. So if you say char of 30, then even if you enter 10 characters or something like that, then you'll be padding with a lot of blank spaces to make it 30 characters. So you can avoid this wastage of memory by, if it's a name, definitely, I would go for varchar of 30 instead of char of 30. Okay, so that's the difference between char and varchar. Now, your again, attributes can also have constraints in their values. Some attributes have to have a value, they cannot be null. So as part of creating the table and defining the attributes, we can also specify if the attribute cannot take null values. We'll see that when we do table creation. And also some attributes need to have unique values, so you can specify that. And also for some attributes, you can have a default value. So if you don't explicitly set a value for that attribute, then the default value that you have configured for that attribute will be assigned to that attribute for a particular row. And then again, for each table, preferably you have a primary key. A primary key again is an attribute that will take unique values and it cannot be null. So those are the two requirements for something to be primary key. And also, if you have say two or more tables, and you want to choose the primary key for an attribute, there's something called candidate key, another terminology. So a candidate key, again, attribute with unique values and not null. It cannot be null. So among the if we have two or more candidate keys, you choose one among the candidate key to be primary key. And you would like the primary key that you choose to be present in at least one other table. So you can link tables or join tables later so that your table is not like a standalone. Okay, so you can connect or communicate or no, pass query between two tables or two or more tables if there is at least one key that is common across two tables. So that's why you want to choose one among the candidate keys as a primary key, such that that candidate key is present in at least two tables. Okay. So if there's no tie and you have only one candidate key, you better choose that as a primary key. Now, also there's something called foreign key that will be a key that's like say roll, there's a student table, and in that say roll number is primary key. And in another table, say attendance, something like that, then you will choose, there'll also be a roll number attribute. It may not be exactly spelled like that, but that's what it means. So it could be spelled like this. But what you can do is you can link the two attributes. So you can say this roll number attribute, which is a column in the attendance table, is the foreign key for the roll number column in the student table. So once you link them with the primary key foreign key in relationship, then the values that this roll number at column can take in the attendance table will be one of the values that this roll number attribute takes in, as a primary key in the student table. So for example, if for the different rows, say you have the roll number to be something like 1, 2, 3, 4, 5 in the student table. Again, it has to be unique and not null. Then the foreign key also has rows. And the roll number attribute in the foreign key for the different rows could be like 1, it could be another 1. It need not, again, foreign key need not be unique, and it could be null also. But the values it takes have to come from the primary key. So it could be 2, it could be 3, but it cannot be 6 because you don't have a 6 as the roll number in the for the primary key in the student table. So the values it could take have to come only from the values taken by the corresponding primary key in the what's called, this is also called where the primary key is there, that table will be called the referenced table. Yes, so that table will be called the reference table, and this table where the foreign key is will be called the referencing table. Okay, so those are the terminologies you need to know. Now let's get started with database creation. So we'll have first a student attendance database. So create database is a command. And then you can pass some name that you want, which is already not there for any database. So student attendance, say database. I think you already have any of all of these. Let's see. Okay, it's already there. So let me create something. It's not there. So backslash exclamation space CLS will clear the screen. So let me create a different name. Create database stu attend DB, something like that. Okay. And you have to end all the queries with a semicolon. If you don't end, it will go to the next line and have an arrow and ask you, it's like waiting for some more text to be entered, but you don't have any more text to be entered, put just a semicolon. Okay, so you can do that in the next line, same line itself. For next time, we'll do like that. So this is like creating a directory. So if now you want to create tables under this database. So you want to get inside the directory and do typically that's when you create the files inside the directory just created. Similarly, you have to create the tables as part of the database that you just created. So you have to use as a command use same database names to attend DB and put the semicolon right at the end. So now the database changed. So previously I was under some database, now it got changed to this one. So now you're inside this. So if you type the command show tables under this and put semicolon, it's an empty thing because we just created a database and it doesn't have any tables. So as you create tables, then they will be listed here. Okay. So let's look at database schema and we'll create some tables. So there is, okay, so here they have specified clearly the database schema for the student attendance database. There are three tables, the student table, guardian table, and attendance table. Let me make sure I'm sharing the screen. Okay. So let's look at the attributes for each table and decide what's the primary key. So they are listed here, but it won't be listed like this for all the exercises. It's just for the first one in the book. So the chapter, so they're listing that. Okay, so just look at the attribute names. Roll number, which is kind of like integer, serial student name, varchar of 20, student date of birth is a date, guardian ID. So each student has a guardian. It could be a parent or a guardian, anyone, but so the guardian ID could be the social security number or Aadhaar number for that person. So it's char of 12. Then the guardian table has guardian ID, the same ID here, that's char of 12. Then guardian name, then guardian phone, which could be unique, but some guardians may not have a phone. Then G address, guardian address. Then attendance table has the attendance date as a date, roll number, which is an int, and attendance status with one character attribute. It could be either present or absent. Now, if you look at this, it's time to decide what could be chosen as the primary key for each table. Now, the guardian ID is there here in the student table as well as in the guardian table. The roll number is not there. So definitely for some student, for each student, you need to pull out the guardian information from the guardian table. So the only way we can pull out that would be to use the guardian ID in the guardian table as the primary key, because the guardian table has other attributes which are not in the student table. So if you make the guardian ID as the primary key in the guardian table and the guardian ID in the student table as the corresponding foreign key, then you can link the two. So the guardian ID will be the primary key in the guardian table. Now, the guardian ID does not have roll number, but using guardian ID, the guardian table does not have roll number or any of these, but the guardian ID is there in both tables. So that will be sufficient to link the two tables. Now, the student and attendance, you have roll number here in attendance and roll number there in the student table. So now student name cannot be unique. Now let's see what can be candidate keys. Student name cannot be unique. Student date of birth also cannot be unique. Now guardian ID could be, it is unique if you use Aadhaar number, but guardian ID is not there in the attendance table because you're not taking attendance for guardian. So you're taking attendance only for student. So the guardian ID could be used to link with the guardian table, but not with the attendance table. So by making the guardian ID as a primary key and here in the guardian table and foreign key in the student table, we can link the guardian and student table. So now how to link the student table and the attendance table? Now, if you think about again here in the attendance table, there are three attributes: the attendance date, roll number, and attendance status. Now, it will be something, the table will have rows, records like this, the attendance table. The attendance date would be, say, some date 2025-08-06, and then this will be roll. So attendance date and then roll number, and then attendance status as present or absent, something like that. So another same date for another student, roll number 2, it could be absent. Then same date for another student, number 3, it could be present, and so on. So now what will happen is you will then record after for some date, for another date, 08, say 07, again roll number 1 present, then 2025, 08, 07, roll number 2 present, and so on. So it will keep going like this. So you will notice that the roll number attribute cannot be unique across all the rows, and the attendance date also cannot be unique across all the rows. So on the other hand, in the student table, the roll number attribute will be unique across each row because the student table will be something like this. Roll number 1, student name, some name, and date of birth and all these things. Then roll number 2, then some name and all these things. Then roll number 3, some name and all these things. So for each student, you are maintaining only one row. So the roll number could be the primary key in the student table, and this roll number in the attendance table could be made the corresponding foreign key. That way you can relate the two tables. Okay. And then also if you want to choose a primary key for the attendance table, you cannot use any single attribute as a primary key because any single attribute does not have unique values or cannot be guaranteed, actually cannot have unique values for across the rows. So, but we can choose what's called a composite primary key. We can combine the two attributes, attendance date and roll number, and look them together as the primary key. So if you think about it, the date and roll number are going to be, the combo is going to be unique across the rows. So no other row will have the same date 2025-08-06 and roll number 1. It will be different entries. So this one has a different date. So the combination could be the primary key. So such thing is called composite primary key. So we could create 2 or more attributes put together as what's called composite primary key. Okay, so that is possible. So let's now start looking at a table creation. We'll create these 3 tables as specified here. Okay, so now you could create tables in any order, but you have to also look at the primary key relationship. So we don't, we'll just designate the attributes as primary key at the time of table creation. But to designate foreign keys, we'll do that using the alter command. Okay, so let's first create the tables, and wherever possible, we'll set the primary keys as well. Okay, let's do create table student. This is a syntax, create table or the keywords, and student is the table name. You can give any name you want. And then you put the open parenthesis, press enter. And then roll number is the first attribute. Again, the attributes can be entered in any order, doesn't matter. But let's just follow what is given. Now space int. Now all the attribute names have to be just one word. If you have, say, city, location, or just any 2 or more words, you just put underscore or just combine them like this as date of birth so that they appear as one word. Okay, so it should not be black space in attribute name. So roll number space int. Now we already decided roll number is the primary key, so we can declare that at the time of defining the attribute itself. So this is how you do that. So immediately after the attribute, you should put the data type. And then after that, you could put any constraint you want on that attribute. So here you want to make it as the primary key. Again, primary space key, then put comma, you're done with that attribute. So put a comma, we'll go for the next attribute, press enter and go for the next row. So next line. Then S name is a student name, and it could be any string of length, say varchar of, I think you're specifying 20. So let's keep 20. Let's make it a little longer, say 30. Then student name, you're expecting it to be something there. So it's not supposed to be not null. So you can say not null as a constraint for this. Put a comma, press enter. Then student date of birth is a date, and it could be also not null. And then guardian ID, GUID, it could be character of 12, a char of 12, because the Aadhaar number is going to have exactly 12 characters. And it's supposed to be foreign key, and we'll do that later. So done with all the attribute names declarations. So we can put the closing parenthesis corresponding to this. So let's put the closing parenthesis and put a semicolon. Then we are done with this. Now let's create the guardian table. Create table guardian. Again, put the opening parenthesis. Then GUID is char of 12. Now we know very well that this is the primary key for this table. So you can put primary key here and put a comma. Then G name and varchar of say 30 or 20. Okay. And it's supposed to be not null. Guardian is supposed to have a name, comma, and then G phone. Now that's supposed to be char of 10. Now phone numbers, we are not going to do any integer processing like math calculations to the phone numbers. So we can input phone numbers as characters. And all phone numbers will have 10 digits. We'll treat each digit as a character. So we'll say char of 10. And now phone numbers are expected to be unique. But if somebody doesn't have a phone, that value could be null. So you see they have specified it could be null, but if it's there, it has to be unique. So it can just specify it to be unique here. And if you don't put explicitly not null for any attribute at the time of table creation, then the database will set that attribute to be of something that can take null values. So I didn't put null here for gphone. So it means it could take null value. So I didn't put not null here for gphone. So it means it could take null values. Okay, so if you leave it without specifying anything about null, then it could take null values. If you don't want it to take null, then you explicitly specified not null like this. Okay. And then G address, it could be varchar of, let's say 40, a little longer, and then it has to be not null. Somebody has to have an address. Now you're done with creating the database. So you could put closing parenthesis and semicolon. Now there's one command called DESC, it means describe. And you want to see the table structure that you just created. So let's say describe student, it will show the structure of the table, means like the schema, the logical structure of the table. So the attribute names called the field, and then the data type for each attribute. Now, if it says no for null, that means that attribute cannot take null values. So remember, for student, we specified the first three attributes to be not null. Once you say something is a primary key, it implicitly means it cannot take null values. And then S name and date of birth are supposed to be not null as well. But the GUID, I didn't specify not null. So that means it thinks that we can have it to be null if we don't enter a value. So GUID could be null. It's not always need to be null. It could be null if you don't enter a GUID. And then the roll number is a primary key. And then even though these attributes cannot have null values, there's a default property. So if you put, again, using the alter command will specify some default value for certain attributes. If you don't specify the default value explicitly, it will be assigned null if that attribute can take null values. Okay, that's how we have to interpret this. Then let's describe the guardian table. So the GUID is the primary key, and the gphone is supposed to take unique values. And the gphone could be null, the other attributes are not null. Okay, so let's create the last database, which is attendance, not last table. Everything is under one database. So create table is a command. create table, then attendance, then opening parenthesis. So roll number is the so you could enter the same spelling for roll number, or if you want it to be different, that's fine. The primary key, foreign key could have different spelling for the attribute name. It's just the link that matters. So let's spell roll number like this here. But the data type has to be the same. It's int. So let's specify int. Again, we want this roll number to be the foreign key. Now, before that, I think the first attribute we want to be attendance state. Again, as I said, it doesn't really matter. But when it's displays, it will display in the order you just insert. You just pass those attribute names. So let's first put attendance date as the attribute. It's a date attribute. So it again will declare the composite primary key after we declare those two attributes. So right now, just put a comma. And then the roll number, as I said, it can be spelled like this. It's an int. Just put a comma. So both together will be the primary key. So let's create other variable also, attribute, and then we'll declare that, which is attendance status. This is char of 1, and it's supposed to be not null. Now, if you want, you can specify a default value for that, like this. So you can put it not null, so it has to be some value. And let's say the default value is present, because mostly the student will be present. Again, you don't say default equal to, you say just default blank space, and the type value it takes 1 character, so you put within double quotes the P for present. And now you are not yet done, so we now have to make these two as a composite primary key. So put a comma, and then the next line, say primary key of, again, primary blank space key of attendance date, comma, roll number. So roll number is spelled like this here. So I have to pass the same way. Put a closing parenthesis corresponding to this opening parenthesis for declaring the primary key. And then another closing parenthesis corresponding to this parenthesis for the table attendance, and put a semicolon. So now we have created this table. Okay. So if you describe attendance table like this, you can say the attendance status by default takes the value P, attendance date and roll number are made the primary key, and they cannot be null. So none of the 3 attributes can take null values. Okay, so now let us see the alter command. So we have created the 3 tables. So now we'll have to link the tables by declaring a foreign key for the tables. Now, a table does not need to have a foreign key unless needed. But so you see, for example, here the guardian table does not need a foreign key. It takes only the GUID as the primary key. So the other attributes need not be any of those attributes can be need to be a foreign key. But the student table needs a foreign key to link with the GUID in the guardian table. So let's do that. So we want to make the GUID in the student table as the foreign key. So the alter has to be done on the student table. So alter table, the student, the table for which you want to add, make something as a foreign key. So use the add keyword, and then the foreign key, foreign space key, and then the name of the attribute. So here it is GUID is the name of the attribute in the student table that we want to make as a foreign key. So we'll make it like passed like this. And as I said, this table is referencing another table, which is a guardian table, and the GUID of that guardian table will be the corresponding primary key. So we have to put the keyword references. So that's a keyword. And then the table name, which is referring to this is guardian table, and the GUID in the guardian table is the corresponding primary key. So this is the foreign key of GUID in the student table, references the guardian table GUID. So put a semicolon. So this is the primary key, and this is the foreign key in the student table. So it has been created. Now, if there's error, it will display an error message. Okay, now we want to make now this roll number in the attendance table as the foreign key for the roll number in the student table. So alter table roll number, so specify the table name first. Alter table attendance as a table name, add. Okay, so alter tables table name, then add is a keyword, foreign key, again foreign space key. The attribute name is roll number, roll NO, references. Student is the table name, and then it is spelled as ROLL number in the student table. So you'll put it as roll number there and put a semicolon. So that's how you create the foreign key. Now, there are other purposes for the alter command also. We will see that in a separate video. Okay. So with this, we can go ahead and insert some values to the three tables and run some queries to look at the records in the three tables. Okay, so there's an insert command which we can use to insert records. So again, since there are primary key, foreign key relationships among the three tables, we need to also be very careful on for which table we are first inserting the records. So the rule of thumb is we insert records to those tables that preferably have only primary keys and no foreign key. Because as I said, foreign keys have to take values corresponding to the primary key. So if I, like this, if I fill this attendance table first and then enter all these roll number values, but these roll number values are not yet, say the student table is empty. So this, you won't have anything here. So that will be an error. So you first fill or insert records into those tables that don't have any foreign key. And then once that means they have only primary keys. So then after you inserted records to those tables, then you can insert records to those tables that also have foreign key. So in our case, we have only the guardian table that doesn't have any foreign key. So we will insert first into the guardian table. So let's see what rows they have here, and we'll insert similar the same thing here. So you can also query if needed. So in your book, they have also shown here some records in each table. Let's see. Okay, it's here. Okay, so let's add these 5 rows. So there are a couple of ways to insert. So the general syntax is insert into. So these are keywords. And then the table name, which is guardian. Now, if you want to insert all the column values for each row, then you don't need to specify anything as the kind of argument for the guardian table. But if you're only filling up, passing specific values for specific attributes, columns, then you have to explicitly list those columns for which you're passing values. So in the first few cases, we are going to pass values for all the columns. So just say insert into the table name guardian, and then blank space, and then say the keyword values, and open and close parentheses. And inside this, you want to pass the first row values. Now, guardian ID is char of 12, so you pass within double quotes. So it is 12 fourths, then comma. Name is also a string, so let's pass this name, comma. Phone is also a string, so 571-149-2685. Then the address G35. Okay. Then put a semicolon. So this will create that row. You can do the same thing for the other rows as well. So this is 12 ones, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then the name. 36129678082. Then let's just say number 5. Yeah. So if you have less than, I think we put 40 characters for ref. So if you put more than 40 to show an error. So it's better to just, that's why I say specify larger size and varchar. Okay, so the third one is 101045678712. So this has to be the phone number is 472-630-9212. /97, say Patel Nagar. Again, MySQL is not case sensitive. If the attribute names could be entered in case uppercase, lowercase does not really matter. Okay, all right. Now for the fourth row, that person doesn't have a phone. So we want to pass values only for the 3 attributes, GUID, GNAME, and GAddress. So in that case, what you have to do is you have to specify, so you have to specify explicitly. Okay, you have to specify explicitly the attribute, that's column names. This GUID, GNAME, GAddress. Then close a parenthesis, and then space values. So this would be the 12 threes, 33333333. And then the name. And then you're not passing the phone number, so remove that attribute value. Then let's enter the address. Okay, so it should do. Now you can pass the same way even if you want to do for all attributes. So all you have to do is add the other column name as well. This G phone. And then the so we have 4 columns. So let's pass the values for the 4 columns. 466, and then 6 4s, 444, 444, 666. And the name. I have to pass the phone number as well. The phone number is 380-192-3168. The address would be, let's say, number 13, B block. You could pass any character, is fine. So we inserted all these 5 rows. So if you want to see the content of the table guardian, you can say select. So select is a query which will be frequently using to retrieve records from the table. So select, you want to retrieve all the records, all the columns. So you put star. So if you want to retrieve specific columns, we will do next, specify that column name. But here I want to retrieve all the columns and for all the rows. So very simple query, select star from guardian. It will list all the columns for all the rows. Okay, so this is how you could do that. Now, let's say I want to just the GUID and GNAME. You can say select GUID GNAME from Guardian, and it will just display those two, GUID and GNAME. Now, what you can also do is, so instead of the caption, so by default will be the attribute name, GUID and GNAME like this. Now, if you want some attributes to be displayed with what do you call more meaningful caption name, you can pass an alias by say as. In this case, I want to do it for GNAME space as. You can say guardian name and from guardian. So you could have blank space in between that So everything put under double quotes, press enter. So instead of G name, it will now print guardian name. You can do it for all the attributes you want, but preferably only for selected attributes will do that like this. Okay, so you can pass an alien. Okay, now we can also filter instead of displaying all the rows all the time. You can what do you call retrieve specific records. So, for example, if I want to, let's put this and clear the screen. So select say GUID and G address from Guardian, where now you know the G name for somebody. If you know the exact spelling, you can pass it like this. So G name equal to, it will be like done as a comparison, and then the name exact spelling, even within even with a period, if you have full stop, you have to pass it. I don't think we have full stop there. So it will print the GUID and G address of that person. But if you're not sure of the exact name of somebody, so let's again look at the table entirely. Select star from Guardian. Okay, so you know there is somebody called Ahuja, but you don't know their full name. So Ahuja is a common last name, it's easy to remember, or Shah is the common last name that's easy to remember. So if you know that someone name has Ahuja in it, but you don't know the exact spelling, so there are some string properties, characteristics you can make use of. Those are covered later in your book, but I'm just telling that right now a little bit. Select, let's again GUID, G phone if you want, and G address from Guardian, where. So here we said G name equal to, that means it has to be exactly equal to that argument we pass. So in this case, Sujata P. But here G name, if you are not sure about the exact spelling, you say like, and then within double quotes, you pass Ahuja. But Ahuja is not the entire G name. There's Amit Ahuja. So there could be some text before Ahuja. So if you put a percentage, it will replace that with any number of characters that appear before Ahuja, and then put the exact Ahuja spelling that you have, that you know that is part of that name. And then there may be some characters after Ahuja as well. So you can also put a percentage symbol. So percentage will replace one or more characters, or even if it's not there, you can say zero or more actually. It will replace zero or more characters with the actual characters out there, if they are there. So in this case, there are some characters before Ahuja, but nothing after Ahuja. But you can still put a percentage symbol both before and after Ahuja. So as I said, even if there's no character after the A in Ahuja, it's okay to put a percentage symbol because you're not sure. And if you put percentage, as I said, it will consider zero or more characters after A for a matching. And here this percentage before this capital A means zero or more characters before this capital A for the matching will be considered. And you're using the like keyword. You should not put equal to. Equal to means it has to exactly match, but here it has to be a like. Okay, it's like a pattern. So it is displaying Ahuja's information. So this way you can query somebody for whose last name we don't know the complete last name, not last name, the complete G name, guardian name, but it is part of some last name or something. It's part of that name. Okay. So let's separate topic on string functions so you can look at that more detail there. Okay, so that's about querying. So let's go back and create the tables, the other two tables. So let's clear this up. So when you're now creating the student table, you have to make sure the guardian IDs we enter are only this, not anything else. One of these for each row. So let's delete, clear the screen, and let's go to student table and create the entries. Okay, so this is the student table. Okay, insert into student, and let's first do all the columns. So just say values, roll number is 1 is an int. So int don't put inside double quotes, just a normal int. And then this is the name of the student within double quotes. And then the student date of birth, passed as double quotes, 2003, 05, 15. And then the guardian ID. So as I said, it has to be one of the guardian IDs we have there in the guardian table. So in this case, all the 12 fours, 5, 6, 7, 8, 9, 10, 11, 12. And we're done. And then let's insert the second one. This is Daisy Bhutia. Then 20020228. Then the last, the guardian ID is 12 ones. Okay. Now for Taslim Shah, we don't have guardian ID. So guardian ID in student table is a foreign key, so it's okay to have it null, means blank, not any specific value. But when you want to insert for such a record, you have to explicitly pass the column names that you are passing the values for. So this is roll number, which I think declared as roll number like this, S name, and GUID. Those are three columns for which you're passing the values. So 3, Aline Shah. Then date of birth is 2002 or 228 as well. And then no guardian ID. So this will be the last one. Press enter. Date of birth doesn't have a default value. Oh, okay. You see, I made a mistake. It shows an error message. I'm passing values for roll number, S name, and GUID as per this, but I'm here. The values have roll number, int, name, string, but GUID is that's what I'm passing here. So it's expected to be a character string, but it's a date format. So it's a mismatch. So I have to change. So I'm passing date of birth, not GUID. So as date of birth. So that's how you get the error message, and you have to, it's not very detailed error message, but you have to kind of figure it out what is going on wrong. So this will be fine. Enter. So now let's have pass all the 4 columns. So after date of birth, and the order has to exactly match as well. So this is 4. Next is S name. Which is John D'Souza. Then this is the date. So 2003, 08, 18, comma, and then double quotes, 333333333333. Okay. Then number 5. This is Ali Shah. 2003, 07, and 05. One zero one zero one zero one zero one zero 10. Okay. For 6, Monica P. 2002, 03, M. 4666436. Okay, so now you say select start from student. So for Talim Shah, roll number 3, we didn't enter a guardian ID, so it displays as null. Okay. So these are the foreign keys, the guardian ID, and the roll number is the primary key. So now that we have 2 tables, we can actually link them and do some queries. And then we'll insert some record for the attendance table as well. So let's select star from Uh, Now, what you can do is you can also query just a student table a little bit, select star from student. So let's say you want to um, display only those students whose year of birth is say 2003. So you can say where year of, here's a key function name and pass the attribute name, which is s date of birth is equal to, so exactly it has to be 2003. To that, put a semicolon. So these are the students whose year of birth is 2003. Now, if you want to find out, say, students whose birth month, you have that as number here, but let's say you know the name of the month, say it's July. Okay, so let's see how many are having July or say February, because February has 02, right? So let's say two people had month as February. So I'll do that. Select star from student, where if you just say month of S date of birth, it look for the S date of birth, it will look for the numerical value, which is 02, right? That's what we want to query. So let's test that with that. You can just say pass two. It's considered as when you extract the individual month, it's extracted as an integer. So you can just say pass two. It will just pull out only those two people whose month of birth is two. Now that's if you use the month function, month alone, month and the day attribute name as date of birth. But if you want to know the name of the month, then you have to say month name as date of birth, and then pass the February in it. Then it will pull out those two people. Okay, so these are some date functions which you can make use of. Now, if you also know, for example, here, nowhere in this date of birth, you don't know whether that date is a Monday, Tuesday, or anything like that, but there is a way you can get it. Again, let me do that. So if I say just day of the attribute name as date of birth, and you want to pull it out, see those people whose day of birth, day means particular date their birth date is 28th. Then across all the years, rows, anybody whose day of birth is 28 will be pulled up. But if you want to know whose birthday falls on, say, or when they were at the time of their birth was on a Monday, so then instead of day, you say day name. So again, month name, day name, you can pass the string. Month name, the name of the month, here the name of the day. So let's say you want to know if anybody or birthday, date of birth was on a Monday. This person's date of birth was on a Monday. So that means 18th August 2003 was a Monday. Very powerful thing to find out. Okay. Now, you can also do one more thing. This is just one value you want to pass. Now, let's say you want to find those people whose day name at the time of the day of birth was either a Monday, say Wednesday, and say Saturday, something randomly chosen. So you can do it like 3 times, or day name as date of birth equals say Tuesday, okay, or day name as date of birth equals say Saturday. 3 times. So day name, day date of birth equals Monday, or day name as date of birth equals Tuesday, or day name as date of birth is Saturday. So in this case, John D'Souza and Alicia. Now, if you want to know this as part of the query itself, you can pass this. Select, say, S name, just say name, and S date of birth, but also the day name of birth, S date of birth. So you can pass something like this. And you can put an alias if you want as, let's do it simply like this. So I just said S name, S date of birth, comma, day name, S date of birth from student where day name is this equal to Monday or day name equal S date of birth equal to Tuesday, this. It will print like this. So S name, that's what you're calling for, S date of birth, and the day name of S date of birth is a Monday for this person and the Saturday for this person. Again, instead of having this caption, which is basically the function that you're calling will display as caption, you can specify a default as an alias name for the day name of S date of birth here as say day name, something like this, then it will print just day name. Okay. Now, instead of putting this R multiple times, you're just comparing the same function day name of S date of birth equals Monday, or it is equal to Tuesday, or the day name of S date of birth equal to Saturday. You can simplify this a lot by putting in, say, instead of equal to in, and pass all the three names within parentheses, Monday or Tuesday, like this, comma, Saturday. So it's not R, but implicitly it means you're doing an R. So in will compare day name of S date of birth with any of these three values, and those will be pulled up. Now, one more simplification is also possible. If you use an alias name for a function that you're calling, or even for a column name, then you can use that alias name instead of that column name or the function name that you're calling here. So that means instead of day name of S date of birth that you're using here to check if it's Monday, Tuesday, or Saturday as part of the where clause, you can pass use this day name alias here. So what you can do is you can do it like this: day name. Again, the what do you call, the uppercase lowercase doesn't really matter because it's not case sensitive. So day name is the name, is the alias name for day name of a date of birth. You can pass that here and get. Oh, you cannot do that. Okay, I thought you could do that. Okay, let's avoid that. So you have to use day name of a date of birth. Okay. There are another scenarios where you can use, but if it is string like this, you cannot use. So let's just stay with this: day name of a date of birth in Monday, Tuesday, Saturday. Okay. Let's clear it up and go to something else. Select star from student. These are the rows. Select star from guardian. Okay. So now what I want to do is, for each student, I just want to print their guardian name. So that requires joining the two tables because I have to retrieve the guardian name using the guardian ID. So I have to retrieve the guardian name from the guardian table using the guardian ID, which is there in both these tables. So the way we do that is, so since you're joining two tables, the attribute names that you are calling for to show up, you will prefix them with the table name as well. So we'll do like select student dot s name, comma, guardian dot g name. And since you are calling attributes from the student table and the guardian table, you say select these two from from clause, you put the table names that you're calling for. Here you have to put student as well as comma guardian. Not only that, we have to link the two tables because we are going to retrieve based on the guardian ID, the matching guardian ID across the two tables. So you have to say in the where clause is where you join or link them. So where student dot GUID equals guardian dot GUID. So it will print now for Alisha. Where is Alisha? The student name. Student name Alisha, which is 101010, that's the GUID here. The guardian name is Himanshu Shah. For Daisy Bhutia, which is all ones, it is Baichang Bhutia. For John D'Souza, which is 43333, it is Danny D'Souza. Mother Ahuja, which is all fours, it is Amit Ahuja. For Manika P, it is 4644, and all this, that is Sujata P. Now you could notice for this record, Talim Shah, whose guardian ID was null, the guardian name was not pulled up because it's not matching, right? Guardian GUID is null there, and all this is the primary key guardian table, so you cannot really match anything. So only 5 students are listed here, not all the 6 students, because this is how you could link. So now you could do that. You could also print the address of the guardian if you want. So select student dot sname, guardian dot rename, comma, guardian dot rename from student, comma, guardian, where student dot GUID equals guardian dot GUID. So you can, sorry, I put G name again, G address. Okay, so you can put the print of the address as well. Okay. All right. So now let us insert into the attendance table. They were not inserted. I think I thought there's one place they did it. Okay, we may have to do it on our own. Okay, so select star from attendance. It's not there because it's empty table. I was trying to describe attendance. So attendance date, roll number, attendance status is for 3-column names. So let's insert some records. Insert into attendance values. Let's put some date 2025 08 say 06, and then the roll number is say 1, and attendance status. Now by default it is P. So you could still pass P if you want, because you're passing all the 3 values. Okay, then for student 2 is also P. Let's say for student 3 it is absent. And for student 4 it is say present. Then for student 5 it is say absent. And student 6 is say present. Let's do one more date. So 07, 1 present, 2 present, 3 present, 4, let's say is absent, 5, let's say is absent, 6, let's say is present. Now, if you want to pass a default value, let's just try for this guy. Since it's default present, you can list just the column names, attendance date, and roll number, and pass the 2 values. You don't need to pass the attendance status because by default it is present. Okay. So if you say select star from attendance now, for the last student, it will be marked present because it takes the default value, even if you didn't explicitly pass them. Okay, so that's how you could make this attendance table. Now let's see some functions here. Now, we want to know what are the days in which the attendance was taken. So there are a lot of duplicate entries for attendance date. So there's a distinct kind of function that you can call select distinct, but it's just a distinct and then the attribute name, no parentheses or anything. Select distinct attendance date from attendance. It will display the what do you call the distinct dates, only those values that are distinct in the attendance date attribute. So that's going to be 06 and 07. Okay. Now, if you want to know the what do you call the day name, let's try day name of distinct attendance date. Whether it's a Monday, Tuesday, or anything like that. Let's try it. That's not possible, right? Let's try it one more way. I pass it inside. No, that won't be possible. Okay, let's forget about that. So you can get the attendance date by distinct attendance date by doing this. You can probably count the, okay, there is another variable called count, which you can use, but let's do it later. Now let's link the tables. So distinct is clear, you can just get the distinct values. Now, if you want distinct on the roll number, you can do that. Attendance. So these are the unique roll numbers that are there in the attendance. Okay, that's understood because you're taking for all the 6 students in the class. Okay, so let's link the tables. Select star from student and select star from attendance. Okay. All right. So what we could do is you could print the attendance date and the student name and whether they are present or not in that date. So select attend. So now you're linking based on the roll number. So let's use the table name, this attendance dot attendance date, comma. I'm not displaying the roll number, but I'm displaying the student name. So it's student dot S name, and then attendance date dot, so not attendance date. Attendance is a table name dot attendance status from attendance and comma student where linking attendance dot roll number equals student dot, it's spelled like this, ROLL number. So it is displaying now the attendance date and the name of the student across the S name and then the P. Now, if you notice, it is pulling out for other Wahuja first across both the dates because it's comparing by the roll number. So it's pulling all the matches for all the attendance dates for one particular student, and then similarly for the next student and so on. Now, if you want to order this thing by attendance date, what we could try is this. So the where clause has to immediately, if you're using where clause, again, where using where is optional, but in this case, we have to use where because we are joining the two tables based on the roll number. So if you're using a where clause, it has to immediately follow the from clause. Okay, so you could use something else also now as you see, but if you use where, it has to immediately follow the from clause. Okay, that's how we have it here. Now I want to display in the increasing order of attendance date. So for example, for all the students on the 6th of August and then the 7th of August. So let's try order by attendance date. And again, it is attendance table, attendance dot attendance date, because you're using two tables here. So it's with the table name and the column name. So attendance dot attendance date. So let's try. Okay, so it is now displaying in the order of the attendance date. So for the 6th for all the students, and then the 7th for all the students. So the order by function can do that. Now, if you want to order by in the decreasing order of the date, so this is an increasing order by default. That's what the order by will do. But if you want to print in the decreasing order, descending order, you can say DESC, order by the attribute name, which is in this case attendance dot attendance date, and then space DESC, that means in descending order. So first the 7th and then the 6th. Now, what you could also do is, let's get back to increasing order. Now, you could order by more than one. So you order by attendance date first, so it will print first for 6th and then the 7th. But now let's say you want to print in the alphabetical order of the student names. So we can order by more than one attribute. So the first attribute will be the first preference for ordering, which is the student attendance date, comma. You can specify the other name column also, attendance dot, or this is from coming from student. So this is comma student dot s name. So it will first order by attendance date, and then we have order comma. You don't say comma order by again. Just say order by attendance dot attendance date, comma student dot s name. So it will then Ali Shah again. It will take the first character to sort. If there's a tie, it breaks by second character. So AL first and then AT, then D, J, M, and then T. Okay, so this is in the alphabetical order. Okay. Now you could also do this order by attendance date. I didn't specify DESC, so it is displaying in the increasing order of the date. But for student name, you want to print backwards. So for example, Kalim Shah first and then Manika and then John, the reverse order. So we could do that as well. So for this, we'll leave it attendance date as it is. But for student.s name, I'll put DESC. It will, sorry, DESC, not DSC, DESC. It will print in the reverse order. Talim T M J D A A. So for student.s name DESC, and for attendance date, just leave it as it is. It will print the increasing order if you don't put DESC. If you put DESC, it will put the reverse order on decreasing order if it's an integer like this for day. Okay. Now, let's try one more thing. So this is start from attendance. Select start from student. Now, let's say for a specific student or a roll number, you want to find the number of days that person was present. Okay. So we can say use the count function, select. Let's first use the attendance table on alone. Select count of attendance status from. Now, count is kind of like an aggregating function. It counts the values of attendance status across the row. So select count of attendance status from what you call attendance, the table name, where roll number equals say 2. So for roll number 2 alone value, you are counting the number of attendance. Let's see. Two, and you want to see the number of days a person is present. So where roll number equals 2 and attendance date, so attendance status equals P. So the number of days the person's roll number 2 is present. So the answer is 2. If you do it for somebody else, the roll number is say 4. The answer is 1. If you do it for, say, 5, the answer is 0. So if you go back, the person with roll number 5 is absent on both the days. So this way you can combine query. So roll number equals 4 and you can say and attendance status equal to P. Now you're querying on the attendance thing, but basically you're trying to find the matching for these two conditions, a matching rows. So roll number equals 5 and attendance state equal to P. So anything that matches these two will be pulled up. So you can query on attendance, count of attendance status, but you can also say count of star. So those rows that are matching will be pulled up as well. That is the number of rows that match will be pulled up. So if it is 2, the number of rows that match is 2. So it is pulled up, that many rows will be pulled up as well. So that's what the count can do. Okay. So let me take a break.